So today's video is going to be maybe a little bit lower effort than usual, and that's because it took all of 5 years, but I finally did catch COVID, and I'm kind of on like the end of it now where I'm feeling good enough to make a video, but maybe not 100% where I can make a fully like in-depth detailed video. But with that, what we're going to be doing today is kind of building the evolution of my 4th ever hand-wired keyboard, the ScottoSlant. I'm going to be doing the ScottoSlant PCB Edition, and it's kind of an excuse to test like a mounting method because this video is sponsored by JLC PCB. They send me free PCBs, so it gave me an excuse to get a PCB for this. But they're also my personal fab of choice. Like the last year, they have really good quality, really cheap and affordable PCBs, and I'll link down below where you can get like some coupon codes if you buy PCBs off there. But with that, let's just jump in and we'll get started. So this here is the ScottoSlant. You can see that we have the top frame of the case, we have the bottom frame, and then the plate, of course. But this here is also the PCB. Like I said, low effort because you can see this stuff here is kind of soldered on already. Basically, I'm just using my method there where I make the holes for the sockets bigger where they sit really nicely in there. But this is what I really wanted to try out with this build, is this like cut out there, because we're going to be using an RP2040 to mount in there, which we'll show later. But the first thing with this build, of course, like any PCB build, or well, maybe not any PCB build, but this one specific, is that I didn't do hot swaps. I'm just going to do some sockets on there, some switches directly soldered on there. So we're going to solder the switches first. And now the switches I'm using are these weird ones right here. These are super cheap. I think I paid like $8 for these, but these are Ajazz like green linears. I don't know how good they're going to be, but they were really cheap, and I think they work really good for this build. So what I'm going to do is I'm going to take those, I'm going to solder them onto the board now, and that's pretty much the entire build, because this PCB is actually already pre-assembled. So it is a assembled PCB where I got the diodes on it from the factory. So you can see that those are all soldered on there. Kind of has some nice stuff in the middle. Dual spacebar here also. So a split spacebar right here where I'll have a dual spacebar to kind of type on. But yeah, I'm going to put those onto the board, and then we can kind of talk about the controller, because that's what's really special. What I really wanted to use this board as an excuse to test is that controller up there. So I'm going to pop the switches on now. So there are all the switches on the board there. Super quick and easy to put on there because the board was basically already assembled from the factory because it had the pre-soldered diodes on there. But the one thing with this that I didn't kind of anticipate when we get into the mounting point here is that you can see we have our sockets here, and this switch was kind of interfering with this bottom socket there. So you probably saw from the top I kind of clipped it. Now that's not a massive issue, it's just kind of something to keep in mind for future like iterations that I try this mounting method. What we're going to do is we're going to put this down. We're going to grab my RP2040. This is an RP2040 if you've never seen one. Super tiny controller, very useful little board. It also has an RGB LED on there right in the middle that can kind of do things. But the problem with this is that you can see the reset buttons and stuff are kind of on the top. So I already flashed the firmware because this is going to sit like that on the board. And you can see the reason I mount it that way is that it kind of gets the clearance of the USB port a little bit lower, whereas if I kind of flip this over and put it that way, it'd be really low and make the board a lot taller. So I'm going to put that down. I'm going to take this, and I'm going to use my method of socketing this with just some standard solid wire. So I'm just going to go through, I'm going to solder that on, and then this should work after I solder the controller to it, because like I said, it already has firmware. So I'm going to go through, do that now. So there is the controller mounted to the PCB. You can see how nice that kind of sits right there. It works out really well. We can look on top of it, and you can see I did my method with the wire where it keeps the solder joints really nice and flush to the actual controller there. Now the one thing with this is that's a little bit hard to access this switch if you wanted to desolder it, because you have to kind of desocket this, which it works out. It's just I don't always like pulling out socket the controllers if I don't have to, but that is the PCB ready to go. We can kind of take this and put it down. I can grab my case here, which we have the top part here. Just has some heat set inserts in it right there, which I did before this video because, well, lower effort than usual, because you can probably hear my voice right now. I feel it's like going sick. So we have those ready to go, but I'm also going to take the back plate. Just kind of sits together like that, but I'm going to put this down. I'm going to put this on there and then put the top frame. And what I could show you here is kind of how that USB sits. So wherever the USB port, I put it in reverse. So let me actually flip that around and then put this like that. And then I can show you that we have the USB port nice and flush right there. So I'm going to go ahead, I'm going to assemble the case, then we can talk about the keycaps after I get that done. So there is the fully assembled board. You can see that I did it in this nice marble PLA. This is Amelin marble PLA. I actually really love this filament because it looks really clean, and it kind of hides all your layer lines completely. So you can see like there are no layer lines there. We have our USB-C on the back there, nicely offset so we could actually plug that in. That's why it's bigger than the port, is because if you actually grab a cable here, you can see that the USB connector itself is normally bigger. So I make them bigger so the whole thing can kind of like fit in there perfectly and kind of sits together. And it also helps if you like knock this, it won't rip as easily because it has that protection around it. But that's the port. We have the back here with the back plate. We have our little rubber feet, all our screws there. And that is the fully assembled board there. Now, what I have to do at this point is, of course, put on the keycaps. I'm going to be using these here, which are just some XDA matcha keycaps that I got on Aliexpress. I think I paid like $12 for these, $10 for these, something like that. But these should be pretty good, so I'm going to go through. I'm going to pop these onto the board. I'll be back after that, where we can talk about the finished board, and then, of course, do a typing test. So let me do the keycaps. But here is the fully assembled board with the keycaps. We have our little boba tea on the left here, and then we have our like cake on the right there. I think they look kind of cool, especially considering they're like $12 keycaps off AliExpress. Looks nice with the marble, kind of goes together, looks pretty cool. But I'm going to put this down. What we're going to do now, of course, is a typing test. These are like the $10, $7, whatever I paid for them. The super cheap Ajazz linear switches here, which kind of feel okay. I mean, they feel okay. They maybe sound okay. We'll go see how it types. So I'm going to go through, do a typing test now, and then we'll have some closing words. So considering that the keycaps and switches combined total was about $20 on this, I think that sounded pretty good considering that. And I do think it would have sounded better if I lubed these space bars here because they are a little rattly there, but that's fine. Like I said, lower effort video than usual because I am still kind of sick. But I think the whole point of this video is that I have to say thanks to JLC because them sponsoring my videos allows me to try out dumb things for you so you don't have to. So on this, I was able to try out that mounting method for the controller and hopefully maybe inspire someone to use a different mounting method like that and see if it would work, because that is an actual very nice method there that you could put it behind the switches, not have to do an integrated PCB, and you can actually use a prefab controller to kind of work like that. So thanks to JLC, I do highly recommend them. Look in the description. There'll be a link down there if you want to get some coupons off your PCB designs. But yeah, I don't really have much else to say here other than I'm starting to get like really bad COVID brain now because it's only been like a week. It hasn't been too terrible, the sickness, but like I've been like thinking and weird and tired and stuff, so I'm trying to sleep that off. So I'm probably going to go sleep it off after this video, because the next video I'm going to actually work on is a wireless split keyboard, because I did already build the Scotto Hazard a few weeks ago. You can find that on my channel, but I actually have some nice nanos and batteries sitting behind me on that shelf there, prepared for a chalk wireless split. It's basically going to just be a 4x5 split, so a pretty simple split, but it's going to be pretty cool, and that's the next one I want to work on. So I want to sleep off the sickness. I'm kind of rambling now. This is the board. I think it came out pretty cool. The files for the case are on the description below if you want to find those. But with that, I don't much else to say here other than thanks for watching. I hope you maybe enjoyed this in some effort or something, because it's very low effort. I don't know how long this video is either, but yeah, comment, rate, subscribe as usual, and I'll see you next time.